So, hi everyone. Now I'm going to talk about the neural network. So, what is a neural network? It's like a human brain, like which has a input layer. It has a hidden layers, output layers. So, it works like a human brain, which is used to learn patterns from data and used to make decisions like classification, prediction, or any recognition. So this is the structure of the neural network. So we have a three layers in it. This is the input layer, which takes input, and this is a hidden layer, which processes that input, and this is the output layer, which it will give us the result. So a neural network is like a system. It learns from examples instead of being explicitly programmed with rules. So we also have a traditional programming and we also have a neural network. So the difference between these two is for traditional program, we'll just give rules plus input so that we'll get the output from those. For neural network, we won't give any rules for this. So we'll just give input, so output examples. Just will give input and output examples. Based on that only, it will learn the rules and it will give us the output. So what does the learn means here? Here learning means just adjusting the internal numbers like weights. Neural network takes weights and so that it predictions become closer to the correct answers. So if we take a simple example, if we want to predict like pass or fail, so we don't tell any rules like if studies hours is greater than 5 then pass. So instead of giving these rules, we'll just give the input as just study hours and attendance. So the output should be pass or fail. So the neural network learns this rule by itself instead of giving by the user. So why only neural network layers means uh, a neural network is made of layers. Why? Because complex problems are easier when we broken it into steps. So coming to the input layer, what it will do is it will just receives the raw data. So for example, like we are giving the 6 for study hours and 80% for the attendance. So no decision is made here. We're just giving raw input. So this is a hidden layer, like where the learning happens here. So what it will do is it will combine the inputs in many ways and learns patterns automatically. For example, so one hidden neuron might learn. So high study hours matter more than attendance. So any neuron might learn attendance matters only if study hours are low. So this is a processing layer and this is the output layer. We'll just give uh, it will just give us like a final answer like a pass or fail, or it will give the 0.92 probability. So this is how it will work. Like layers allow the network to think in stages, not all at once. So instead of giving all at once, it will give in layers format, like taking the input and processing that input and giving the output. And how a single neuron thinks, like a neuron makes a small decision based on the input. So based on our input, it will make some decisions. So step by step inside a neuron, like it will take input values and it will multiply each input by a weight, and then it adds everything together and it will add the bias like adjustment and it will apply activation function. So this is how it will work. So this is a mathematical view. So here x1, x2 are the inputs and w1, w2 are the weights. So we are multiplying that weights with inputs and then we are adding it. So we are adding this bias like adjustment. We are also adding this to uh, these weights, and then we are applying this activation function. Like so for this z, I'm applying this activation function. So activation of z, that will be written as a output. So here, weight means how important is this out input. So how important? So here bias means like adjusting. So how strict should the neuron be? And then activation means should I activate or not? So coming to the loss functions. So what is a loss function? Why loss function is needed? A loss function means it tells the neural network like how wrong it is. Instead of just saying like wrong, uh, it will just say as like in numerical format like 0 or 1. So why can't we just say wrong? Computers don't understand it like right or wrong, good or bad. So they just understand only the numbers. So that's why this loss converts error into a number. So for example, actual result is a pass and model prediction is a fail. So loss tells how bad is this mistake. So here a loss is like exam marks. It tells how badly you performed. So we have some regression loss functions out there. So one is mean squared error. So the formula for this is loss equals to actual minus predicted whole square. So why we are squaring it is like small errors equals to small loss. If it is a big error, we'll get a big loss. For example, the actual value is 10 and the predicted value is 7. So the error will be 3. So here the loss equals to 9. So the problem with mean square error is if one data point is very wrong, it dominates the learning. So this is the mean square error. And we also have a mean absolute error. So loss equals to mod of actual minus predicted. So why mean absolute error means it treats all errors equally and it will stable when data is noisy. So compared to this, mean square error is a strict one and mean absolute error is just forgiving. So previously I said this regression loss functions. Now I am going to talk about the classification loss functions. So here this is a binary cross entropy like yes or no problems. This is used when output is just a probability. So important idea here it is. If if it is correct and confident, we'll have very low loss. So if it is wrong and confident, we'll have a very high loss. For example, actual equals to spam of 1. So the prediction is 0.99 and the prediction is 0.01. So if we get the 0.99, it is a small loss. So if we get 0.01, it will be a very huge loss. So why this is good means it teaches the model like don't be confidently wrong. So now I'm going to talk about the gradient descent. So what problems these gradient descent solves means here. So what is a gradient means it tells like if we slightly change any weight, how will the loss change? So to calculate the loss, we are using this gradient. So here training means finding the best weights that give minimum loss. So the purpose of this is to reduce or to minimum the loss. But loss function is complex and it has many weights, so no direct formula to solve. So here we use trial and improvement. And gradient descent idea is it should start with the random weights and it will slowly improve them and move in the direction that reduces the loss. So here what is a gradient means it will tell like if we slightly change a weight, it will how will the change law how will the loss change. So here large gradient means weight is very important. For small gradient, weight is less important. So we'll have a rule like we'll have a formula like new weight equals to old weight minus learning rate into gradient. So y minus means it will gradient shows where loss increases. We move in the opposite direction. So here a learning rate explained simply here. So learning rate decides how big each step is. If it is too large, we just jump over the best solution and then training becomes unstable. If it is too small, learning is very slow and it takes too much of time. So for correct learning rate, it is a stable learning and faster convergence. So learning rate is like walking speed while climbing down a hill. So this is a back propagation. So what really the back propagation means? Sending the error backward to find the who caused it. Like whatever the error we may get from the input layer to the in the hidden layer, that will be sent back to the input layer. So why this is needed means many neurons contributed to the output. So we must know which neuron made how much mistake. So propagation assigns blame correctly. So how it will work means it has two passes. Like one is forward pass and one is backward pass. So for the forward pass, we'll have like we'll just give the input and we'll get the output. So here it will calculate the prediction. So while in backward pass, it will give us the from the output it will give the input. So it calculates the gradients. So we'll have a chain rule idea also. Oh, if output depends on the hidden layer depends on the uh, so if the output is depends on hidden layer, then the hidden layer depends on the weight. Or else if the loss depends on weight, back propagation calculates this efficiently. So this is how the this is what the neural network and loss functions, back propagation and gradient descent. So thank you.